Okay, so let's try our integration by substitution method, and we're going to use our replacement of variable and using our substitution right here for our limits of integration using the method of substitution. So how's this going to work out for us? Well, in this case, let's make our substitution right away. We can see that it looks like we're going to let u replace the expression cosine of x. And of course, that means that the derivative of u is going to be the negative of the sine of x dx. So making the replacement right here, negative du will replace sine of x dx. The other thing that we'll note is that we can replace our end values right here in our expression as follows. U is going to be, let's see, u of 0 is going to be the cosine of 0, and we know that the cosine of 0 is equal to 1. That's a 0, not a theta right there. And of course, u of pi over 3 means we're going to be taking the cosine of pi over 3. And remembering back to what we remember about cosine functions in pi over 3, we get 1/2. All right, so how does that look? Well, in our new expression, our new integral, we're going to have the negative of the integral from 1 to 1/2 of u to the 1/2 power du. And you might remember the property that states that if we have an integral of a function on the set from a to b of f of x dx, that is the equivalent of taking the integral from b to a of f of x dx. And so when we rewrite this expression, this is really going to be our integral from 1/2 to 1 of u to the 1/2 du. So let's see how that's going to look. That would be 2/3 of u to the 3/2 power when evaluated from u equals 1/2 to u equals 1. We're going to have 2/3 times 1 to the 3/2 minus 2/3 times 2 to the 3/2 power. The first one's a little bit easier to handle. 1 to any power is just 1. So we've got 2/3, and we're going to be subtracting away from that 2/3 of this root, the square root of 2 cubed. Another way of stating that, the square root of 2 cubed is the square root of 8. That's 2 times the square root of 2. Interestingly enough, that means that we're going to have 2 minus 4 times the square root of 2 all over 3 as the value of our integral right here from 0 to pi over 3 sine of x square root of cosine of x. And you'll notice that nowhere in the work did we even need to resort back to dealing with sine and cosine, because we did all that work up front. And that makes us happy. Good luck on your assignment.